Hi everyone, today in this video we are going to look about the ionization energy. I'm Nusra from Tutopia. So what is ionization energy? We know in an atom we have three subatomic particles called proton, neutron and electrons. So normally we do have the subparticles protons and neutrons in the nucleus of an atom. So if we have four protons, yes, we are going to have some neutrons in it, which makes the mass number in total. And we are going to have equal number of electrons of the protons. The number of protons will be equal to the number of electrons. So we are going to have 4 electrons, and the energy that is needed for us to remove one electron from the outermost shell, to remove one of the electrons from the outermost shell, is known as the ionization energy. Since this electron is being attached with this atom and orbiting around these nucleus in this atom with an attraction force, an electrostatic attraction force towards the nucleus, removing this electron requires an energy which is called the ionization energy. So when an electron is released, we know now the number of electrons is not equal to the number of protons. We had 4 protons and 4 electrons earlier. So we had 4 plus charges and 4 negative charges. The overall charge was 0. So an atom is neutral by the charge. But when we are removing one electron, we have 4 protons but just 3 electrons. So we have an overall charge, positive 1 overall charge. In that case, using this ionization energy, when one electron is removed, it will result a cation, a positively charged ion, which is called a cation, and a negatively charged ion is called an anion. What is successive ionization energy? As we were speaking earlier, removing the one of the outermost electrons is known as the ionization energy. And according to the increasing order of energy, we can keep on removing the upcoming electrons. So if we are removing this electron first and this electron next, the amount of ionization energy required will not be the same. So ionization energy will not be the same when we are removing different electrons from an atom. When we have to remove the next electron, we have to move to another inner shell. So it is going to require high energy comparing to the first 2 electrons. So successive ionization energy, it is the energy required for removing the consecutive electrons, the successive electrons of an atom. So successive ionization energies will always increase. It's because we have to go to inner shells, and this electrostatic attraction will be greater when we are moving to the electrons of inner shells. What are the factors that affect the ionization energy of an atom? The first factor is size of the positive nuclear charge. That is, we know by the mass the positive charge is having 1 AMU, whereas the negative charge, that is the electron's mass is 1,800 times lesser than the mass of proton. In that case, when one proton is being added, the electrostatic attraction is going to increase because of the charge. So whenever we are keeping on adding a proton, the ionization energy will increase. The reason is, if you have the nucleus with protons and the electrons orbiting around the nucleus in the energy levels, So here we have to know that we have 3 electrons and 3 photons. So these 3 electrons are being held within this atom by the electrostatic attraction towards the nucleus because of the opposite charges. But moving ahead, if we are having 4 protons and 4 electrons, we cannot expect this attraction to be the same. Since we are adding one more proton, the attraction will be greater. So adding one proton increases the electrostatic attraction towards the nucleus. So moving ahead in the periodic table, when the atomic number increases, that in other words, when the number of proton increases, we will be having greater ionization energy. So in the periodic table, if we are moving left to right, the ionization energy should be increasing because of the number of protons being added each time. The second factor that we can speak about, the factor that affect the ionization energy of an atom, is the size of the atom, or in other words, the radius of the atom. So let's compare 2 atoms which has just 2 shells and another one with like 4 shells, 4 energy levels. So here the first atom that is atom X and atom Y. The atom X has its outermost electron in its second shell. There can be few electrons. So removing this electron requires greater energy comparing to removing this electron of the atom Y, the outermost electron of the atom Y. It's because since this is closer to the nucleus, the electrostatic attraction is going to be greater comparing to the electrostatic attraction of the atom Y for its outermost electron, because the atomic radius of atom Y has been increased. So the second factor that affects the ionization energy is size of the atom, in other words, the atomic radius of an atom. As atomic size increases, the attraction of the positive nucleus for the negative electron decreases because of the distance that it has between the nucleus and the electron, and less energy is required. So when the attraction is less, to remove that, it is easy to remove that electron. So the ionization energy to remove that electron is less. This means that the ionization energy decreases when the atomic radius of an atom increases. The third factor that affects the ionization energy is the shielding effect. And a shielding effect is the outermost electron is screened or shielded from the attraction of the nucleus by repelling effect of the inner electrons, and as shielding increases, the attraction of the positive nucleus for the negative electron decreases, and less energy is required to remove an electron. That means the ionization energy decreases when the shielding effect increases. So if we are trying to put this into a diagram, let's say this is the nucleus, and here we have 3 subatomic particles that are, 3 energy levels. This is where we are going to see, this is where we are going to have our last electron. That is the electron from the outermost energy level. The attraction for this electron, the attraction, electrostatic attraction between the nucleus and the outermost electron, is shielded by the electrons from the inner energy level. So we are going to have electrons over here, and these electrons with this positive nucleus has the electrostatic attraction. So they do shield the attraction of the outermost electron. If it is shielded, the attraction becomes less. If it is increasing, if it is decreasing, if the attraction towards the nucleus decreasing, it's easy for us to remove this electron. That means the ionization energy here decreases when the shielding effect increases. So the first factor that affects the ionization energy is positive charge adding proton each time. So when a proton is added, the attraction increases so that the ionization energy decreases. Second factor is the size of the atom, that is atomic radius. When the atomic radius increases, attraction decreases so that the ionization energy decreases. Third factor is shielding effect. When the shielding effect increases, the ionization energy decreases because the attraction decreases. How do you explain this trend? So moving from left to right through the periodic table, we have ionization energy increases. The reason is protons being added. So each time when we are moving from boron to carbon, carbon to nitrogen, one proton is being added. And the ionization energy decreases moving down towards the group. The reason is atomic radius. Atomic radius is increasing moving down through a group. When the atomic radius is increasing, ionization energy is decreasing. So this trend can be explained using all three factors that we studied. I have gone with a simple explanation, but all three factors, that are shielding effect, adding a proton, and then the atomic radius, can be said as the reasons for this trend to be observed. So according to this periodic table, the ionization energy of neon has to be greater and fluorine should be next, oxygen, and then nitrogen, carbon, boron, beryllium. We have to observe this trend according to this fact given over here. But when we are actually calculating the ionization energy, there is a drop between beryllium and boron. And the oxygen, the ionization energy of oxygen that comes next to nitrogen in the periodic table has to be greater, but there is again a drop. So the reason for these exemptions can be discussed in our next slide. So ionization energy, the reason is boron and beryllium. Boron, what we expect to have is having greater number of or greater amount of ionization energy for beryllium than boron. But what we observe is beryllium lies here. What we are expecting according to the periodic table is boron having greater ionization energy than beryllium, but actually the boron is having less ionization energy than beryllium. The reason is the atomic number of beryllium is 4, whereas the atomic number of boron is 5. So if we are writing the electronic configuration of the beryllium, it's 1s2, 2s2, whereas for boron, it's 1s2, 2s2, 2p1. So removing this electron from boron makes the boron a stable element by having a stable configuration. So since it stabilizes the atom, when we are removing one electron, it will require a less amount of energy, which can be done easily. But here, if we are removing one of the electrons, the atom becomes unstable because the configuration turns into 1s2, 2s1. In that case, removing one electron from beryllium requires greater energy comparing to boron. Nitrogen and oxygen, what we expect to have is oxygen having greater ionization energy than nitrogen. But what we have is nitrogen is having greater ionization energy. The reason, nitrogen, the atomic number of nitrogen and oxygen is 7 and 8. And if we are writing the electronic configuration, it will be 1s2, 2s2, 2p3, whereas it is 1s2, 2s2, 2p4. So removing one electron from nitrogen makes that atom asymmetrical, and removing one electron from oxygen makes that atom a symmetrical one. So that removing one electron from oxygen becomes easier and the ionization energy becomes lesser, whereas the ionization energy of nitrogen becomes greater, because when we are removing this electron, the atomic configuration, that is the electronic configuration of nitrogen, becomes asymmetrical. But here it turns into symmetrical when we are removing this electron. So it requires less energy comparing to the ionization energy of nitrogen. So all these exceptions over here, comparing with magnesium, all these trends can be explained using those facts. Magnesium and silicon, phosphorus and sulfur, everything can be explained using those facts. So that's it for today in this video. So far in this video, we have discussed about the ionization energy. And the ionization energy is the energy required to remove the electron, the outermost electron, one of the outermost electrons from an atom, resulting a cation. And this ionization energy is depending on three important factors that are shielding effect, atomic radius, and the proton charge. And moving through the period from left to right, we do expect the ionization energy to increase because we are adding one proton each time, but there is a drop when we are comparing beryllium and boron. The reason is electronic configuration and the stability of the atom. So almost all the drops and exceptions on that ionization energy graph can be explained using these reasons. So that's it for today. We are winding up with this note, and let's meet with in another video with a fresh concept. Thank you guys. Bye.